Hi, I'm Mr. Huber, and in this video I would like to talk about quadratic functions. A function that looks like this: f of x is equal to x squared. But before we do that, I would like to talk about something we already know, a type of function we already know. F of x is equal to 2x plus 1. Well, we all know that this function is easy to draw. You go through 1, that's the y-intercept, then 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right, 2 up, and so on. 1 to the left, 2 down, 1 to the left, 2 down, and so on. You know how that works. Okay, here we go. That's the graph. Now, when we first introduced this type of function, we started off like this: x, f of x, and we set up a table. So -3, -2, -1, 0, 1, 2, 3. Then f of -3, that's 2 times -3 plus 1, so that's -5. F of -2 is 2 times -2 plus 1, so that's -3. F of -1, that's 2 times -1 plus 1, that's -1. Then f of 0, 2 times 0 plus 1, obviously that's 1. Then f of 1, 2 times 1 plus 1, that's 3. Well, you get the gist, and this is how it continues, 5 and 7, okay? And now you can clearly see the points on the graph, because, for example, at 2, we do have a y value of 5, so this is 2, 5. At 3, we do have a y value of 7, so it's 3, 7. Let's go for -2. At -2 here, we do have a y value of -3, so that's -2, -3. That's how you can plot the graph, okay? But we don't have to do that anymore. We don't have to set up tables anymore, because we know the pattern. We know every function of this type is in fact a straight line, and we can draw every function of this type. But now with the new functions, we don't know what they look like. Well, we're going to start off with this first function here, and we have to set up a table because we don't know what the graph is going to look like. So -3, -2, -1, 0, 1, 2, 3. F of -3, that's -3 squared, that's 9, okay? Don't make the mistake that you forget the brackets, because look, here we go. Brackets -3 squared, that's 9, okay? But then if you type in -3 squared, that's -9. Please be careful. You have to have these brackets, because look, let's write that up here. -3 squared, that's -3 times -3, that's obviously 9. But -3 squared, that's -3 times 3, and that's -9. So this is not what we want. We want to plug in -3. So f of -2, let's carry on. So that's -2 with the brackets, that's 4. F of -1, that's -1 with the brackets, that's 1. F of 0, 0 squared, that's 0. F of 1, that's 1 squared, that's 1. F of 2, 2 squared, that's 4. and f of 3, that's 3 squared, that's 9. So 0, 1, 4, 9. Now we can plot the graph. At 0, we have a y value of 0. At 1, we do have a y value of 1. At 2, we do have a y value of 4. At 3, we do have a y value of 9. At -1, it's 1. At -2, it's 4 again. At -3, it's 9. So you can see it's symmetric with respect to the y-axis. Now we can plot the graph, draw the graph. And you can't just connect the dots. You have to connect the dots in a smooth way. Smooth and rounded manner, okay? Smooth and rounded curve. Here we go. Obviously, we could have plugged in all the numbers in between. For example, we could have said, what's 5 halves? Well, here at 5 halves, well, f of 5 halves, that would be 5 halves squared, which is 25 quarters, which is obviously 6.25. So 6.25 or 25 quarters. So at 2, we're at 6.25. So this point is in fact 2.5. And the y value is 6.25. 6.25. Here we go. This is the point here. So it lies on the graph. And when you plot all or when you calculate more than these points, you will see that it is a rounded shape, okay? A smooth, rounded shape. So please keep that in mind. You see, that wasn't too difficult. Well, we have to get to know this type of function now. And maybe eventually we will see a pattern. And we will be able to draw every quadratic function there is. Like we are here, we can draw every linear function we want because we know the pattern. So now everything that we need to do, or everything that we have to do, is to see a pattern here, to find a pattern. Okay, I hope it wasn't too difficult. See you in the next one.